Inside most local development environments, high-value secrets live in the open. Hidden configuration files contain raw database passwords and cloud API keys stored in plain text. In May 2026, xAI launched a product designed to sit directly alongside these sensitive files. Grok Build was a terminal-native agent, a $299 a month subscription service that promised to automate complex engineering tasks from within the user's local directory. The tool utilized a massive 256,000 token context window. This architecture allowed the system to orchestrate up to 8 concurrent subagents, enabling it to refactor code, generate tests, and manage dependencies all at once. Because the interface lived in the terminal and operated on local files, developers treated it with a level of trust usually reserved for local compilers. It felt like a private, sandboxed tool. This appearance of security masked the reality of how the tool handled data. By operating with full access to the local file system, Grok Build was positioned to see everything. That trust evaporated on July 14th. Across developer forums, warning signs flashed as security researchers looked under the hood of the Grok Build binary. The investigation was led by a researcher known as Cereblab, who conducted a systematic wire-level audit of the tool's outbound traffic. The audit revealed a massive background operation. The tool was quietly harvesting and exfiltrating entire private Git repositories, sending the data to a Google Cloud bucket managed by xAI. Across X and developer forums, the revelation raised an immediate, urgent question. Was a premium productivity tool actually a Trojan horse for corporate espionage? To find the smoking gun, the researcher configured a local interception proxy to decrypt outbound HTTPS requests. The logs revealed a dual-stream architecture. Channel A carried the actual AI chat, while a separate, undocumented Channel B made bulk post requests growing alongside the codebase. The researcher designed a control test to see if the tool would follow orders. They loaded a 12-gigabyte dummy repository and gave the AI a specific instruction. Reply exactly OK, do not read any files. While the AI followed instructions, Channel B ignored them, immediately uploading gigabytes of data in sequential 75-megabyte chunks. This brute force upload of the entire project directory occurred the moment the session began, proving the tool wasn't just selectively reading code. The exfiltration was baked into the software's basic design, engineered to collect bulk repository data independently of the user's intent. The extraction method targeted the underlying Git history. By packaging the repository as a raw Git bundle, the tool captured every historical commit, sweeping up sensitive data that wasn't even in the active folder. Developer Peter Dedeen saw the consequences firsthand. When his repository was exfiltrated, the bundle included large design files he had deleted years prior. Because the tool took the whole history, anything ever committed to the project was now sitting on xAI's servers. Even more alarming was the failure of client-side privacy controls. Many users had already selected the Improve the Model opt-out toggle, which was legally supposed to prevent this kind of data retention. The wire logs proved the button was a surface-level aesthetic. The server continued to return an overriding flag that enabled the upload, forcing the local binary to send the data regardless of the user's choice. In the proprietary AI world, user privacy toggles often function as aesthetic shells, masking aggressive background telemetry the user cannot actually disable. As the audit findings went viral, the industry's biggest players used the crisis to reposition themselves in the market. OpenAI CEO Sam Altman publicly targeted his competitor. He labeled the incident concerning and used the breach as a reason for developers to abandon xAI's ecosystem in favor of open-source frameworks. Elon Musk responded with a series of drastic damage control measures. He confirmed a retroactive purge of all developer data from xAI servers, promising that everything uploaded before the crisis would be permanently deleted. Musk promised something the platform had previously refused. He pledged to open source the entirety of X's codebase, offering to let third-party reviewers verify the code running on his servers. But for many developers, the corporate fallout was beside the point. The crisis proved that trusting any cloud-tethered provider with raw source code creates a central point of failure that no open-source pledge can fix. In response, a grassroots movement has formed around local sandboxing. Developers are now using isolated Linux namespaces to physically lock the AI agent away from the rest of the system. This bubble wrap method creates a wall between the tool and the internet. It allows the agent to process code locally while removing any physical path it could use to send that data back to a corporate server. The long-term solution is a shift toward models that don't need the cloud at all. New architectures like PrismML's Bonsai 27B are designed to bring advanced reasoning directly to the local machine. Through one-bit and ternary quantitation, a massive 54-gigabyte model is compressed into simple binary representations, shrinking to fit a standard laptop. This extreme compression retains original intelligence, allowing complex offline tool calling and multi-step planning at speeds rivaling cloud APIs. The Grok Build crisis moved the security boundary. It demonstrated that while AI reasoning can be outsourced, the privacy of the codebase must remain anchored to the local machine.